Hi students, in this class we are going to study the ABCD constants of nominal pi network of transmission lines. This is a 4-terminal 2-port network. This is our sending end port. This is our receiving end port. For any 2-port network, the sending end voltage and the sending end current can be written in terms of receiving end voltage and receiving end current. ABCD are constants. All these parameters are vectors. Voltage, current and ABCD constants all are vectors. Now we are going to write the ABCD constants and the equations for Vs and Is for this pi network of our transmission line. As you know, in the pi network, half of the capacitance is at one end and half the capacitance is at the other end. This is our impedance. Now let me write the sending end voltage equation first. Vs is equal to, as you know, the source voltage or the sending end voltage equals the receiving end voltage plus the drop in the transmission line. That is VR plus IL into Z. But this IL equals, IL splits into two parts. One flows through the load, that is our IR. The second part flows through this capacitor. So IL equals IR plus IC1. So this can be written as VR plus IL equals IR plus IC1 into Z. So this is equal to VR plus IR plus IC1 is the current flowing through this capacitor, which is equal to the voltage across the capacitor into admittance. Here the admittance is Y by 2 into Z. So this is equal to VR plus IR into Z plus VR into YZ by 2. So Vs can be written as VR into 1 plus YZ by 2 plus IR into Z. We have to write the sending end voltage in terms of receiving end voltage and receiving end current. So Vs equals VR into 1 plus YZ by 2 plus IR into Z. So we got the voltage equation in terms of receiving end voltage and receiving end current. Now we have to write the current equation, the sending end current equation. Is equals, now if you look at this network, the sending end current equals IL plus IC2. IL has two components. A part of IL flows as R and a part of IL flows as IC1. Then a portion of the source current flows through this capacitor. So total Is equals IR plus IC1 plus IC2. This is the total source current. So this is equal to IR plus IC1 is the current flowing through this capacitor, which is equal to voltage across the capacitor into admittance, VR into Y by 2, plus IC2 is the current flowing through this capacitor, which is equal to voltage across the capacitor into admittance. So this is equal to IR plus VR into Y by 2 plus Vs can be written as VR into 1 plus Yz by 2 plus IR into Z into Y by 2. This is equal to IR plus VR into Y by 2 plus VR into Y by 2 plus VR into Yz by 2 into Y by 2. VR into Y square Z by 4 plus IR into Yz by 2. So IS can be written as, first we have to write the receiving end voltage part, VR into, here we have Y by 2, this is also Y by 2, Y by 2 plus Y by 2 equals Y, plus here the coefficient of VR is Y square Z by 4 plus IR into, here the coefficient is 1 plus here the coefficient is Yz by 2. So now we got the sending in current also in terms of the receiving end voltage and the receiving end current. So we can write IS is equal to VR into Y plus Y square Z by 4 plus IR into 1 plus Yz by 2. So this is our sending in current equation in terms of VR and IR. So this is our constant A, this is the constant B. Here the coefficient of VR is C, this is the constant D. Our constants are A, B, C, D. For any network, A will be equal to D and AD minus BC will be equal to 1. Now if you know the impedance and admittance of the network, you can easily find out ABCD constants. Once you get the ABCD constants, if you know the receiving end voltage and the receiving end current, we can find out the sending end voltage and the sending end current.